So our last conic section is the hyperbola. And so I thought I would add to what you've already read to in the book by just giving you my own explanation. What's written here are the general forms of the hyperbola that are on page 659. And so I want to make sure that we know how to find the vertex, the center, the vertices, the focus points, as well as the asymptotes that are involved with this, because hyperbolas will follow asymptotes coming out. And the asymptotes are easy to find. All of this is easy to find. So we have two things that could happen. Notice how you're going to tell whether you have a hyperbola. One of the variables both variables will be squared, and they'll be opposite signs of one another. And so everything happens to the positive squared one. So if I look at this first example, everything's going to happen to the x. So what's everything? Well, the center is going to be at HK. The vertices are going to be at H plus or minus AK. Again, everything happens to the positive squared variable. The focus points, well, you know what those are going to be. They're going to be H plus or minus CK. Now, I got to have you have a picture of what's going on here. So if the center was at HK, let's suppose that that is HK. The vertices would be in the x direction out a distance A, right? So we'll say that that's A. And those are my vertices. And the hyperbola opens up this way. And what the focus points are they're inside. So they're farther than A away. So that farther distance is the C distance. So C squared is not going to be A squared minus B squared. It's going to be A squared plus B squared. We actually could care less whether A or B is bigger in this case. Everything happens to the positive squared variable. And so C squared will be equal to A squared plus B squared. There's one other piece of information, and that is the asymptotes. And the asymptotes are always the same. They're going to be y minus k, because they're a linear equation, so it's a y equals equation. And it's plus or minus what's underneath the y over what's underneath the x square rooted, right? So in this case, b over a, x minus h. That's how it always looks. And so we'll get really good with this. So equivalently, if I come over and erase some of this stuff over here and work this other one, if we go to this second version, which I'll do in blue, well, its center is at h comma k, right? Still x, y. It has vertices, and everything's happening to the y, so now it's k plus or minus a. I put that a underneath that non-squared 1. The focus points are going to be h comma k plus or minus c, and the directrix line will still be y minus k, still be plus or minus, and it will still be x minus h, and it's always what's underneath y square rooted all underneath what's underneath x square rooted. Now, why should that make sense? What's underneath y, what's underneath x? Because that's your slope. And slope was always y's over x's. So it's very easy to remember those asymptotes setups. And we'll see that as we go and do different examples together.